I'd like to welcome everybody to the webinar today. Have a lot to cover, so we'll get going and have at it. We are going to go through some of the major changes in the 2011 code. I'll do a short overview of strength design, flexure design, then beams, lintels, then we'll go to flexural and axial loads, which primarily relate to bearing walls, and then we'll do shear and shear walls. So that will be the outline for today. So we'll start out, just let me highlight for a few minutes here some of the major changes between the 2008 and 2011 Masonry Code. The first one is code format. The code and commentary are now side by side. Hopefully that will help the users. We have updated the ASC 710, and I'll mention the implications of that in a second. We have added in some deep beam provisions. I have an example in the notes here. Due to time, we won't have much time to go through that, but there are deep beam provisions. I will talk briefly about some of the modifications of lap splices and quality assurance tables. The grout lift height has been changed to 5 feet 4 inches to accommodate modular construction. It used to be 5 feet. The 5 feet 4 inches matches more with the 8-inch typical unit height. And there is also a new appendix, Appendix B, on infill masonry construction. We will not be covering that today, but wanted you aware of that. So just a few slides related to the changes. Again, we changed the format, so the code is on the left, the commentary is on the right, so those are matched together. Hopefully that will help the user easily find things in the commentary. We have updated to ASC 710 strength load combinations. The big change is, of course, that the wind load was changed. So in ASC 710, the wind load is now at a strength level, a load with a load factor of 1. So this resulted in some of the triggers being changed for veneer and glass unit masonry and prescriptive provisions there. Lap splice provisions, 2 changes between 2008 and 2011. We have the same lap splice equation, the development length, same length is used both for splice and development, but we have our equation here when there's this factor K, which is the minimum of the masonry cover, the clear spacing between adjacent splices, and it used to be 5 times the bar diameter, and it is increased now to 9 times the bar diameter based on re-looking at the test results and going through that. So this is a quick table just to show you the impact of that for both 8-inch concrete masonry units, 12-inch concrete masonry units, the splice length required in the 2008 code, and the splice length now required in the 2011 code. So for smaller bars, 3s, 4s, and 5s in that range, the splice length is a bit smaller in the 2011 code, so provides a little more economy in terms of construction and also constructability. Once you get to larger bar sizes, then K starts to be controlled by that masonry cover instead of the 9 dB. The second change that was made in lap splice requirements was the inclusion of transverse reinforcement or confining steel here. So if number 3 bar large is placed transversely within the lap, you have to have a bar within 8 inches of each end of the lap. The transverse bar has to be within 1.5 inches of the lapped bar. You're actually allowed to then reduce the lap length by this factor here. So A sub SC is our area of a transverse bars, a limit on that of 0.35 square inches. So here's a quick example. A number 6 splice, 8-inch CMU, number 3 transverse bars, a reduction factor is 0.481. So splice length gets reduced to 21 inches. However, there is a minimum splice length of 27 inches. So just another quick example. This is for 8-inch CMU bars centered in the wall. The transverse does not really help you with smaller bar sizes. In fact, if you actually go through the calculations, it gives you slightly larger values, the 36 dB. So you just use these values for your splice length. But as you can see, when you get number 6s and above, 7s, 8s, up in that range, if you're having to use these larger bar sizes, then the transverse reinforcement can decrease the amount of splice length that is needed.